So our next step in physics is acceleration. Now we're using acceleration because really acceleration is an application of all three: gravity, wind, and friction. You need acceleration to do any of these. So basically your character is going to move at a certain speed, and that speed is going to accelerate. So it's going to get bigger and bigger and bigger every update until it reaches a maximum speed. So let's say, for example, if you're playing a game and your character just always moved at 5 pixels per update, that would work just fine. There's no issue with that. The character would just instantly move, instantly stop. It just might be a little bit jarring for the player, but there's lots of games out there that do exactly that. So there's no issue with that at all. Now what we want to do is we want to create a much more smooth experience. So what we're going to do is we are going to accelerate and decelerate. Let me just get rid of that. So we're going to accelerate and we're going to decelerate our player. So what this means is that every update our character is going to have a certain speed. Now we're going to keep it simple for this demo, and we're just going to do it horizontally, and then you can apply it to vertically later. So they're going to have a certain speed. That means they have a vector, but their vector is going to have a value. It's an x value of speed and a y value of 0, because it's not being applied in the y direction in any way, shape, or form. So its direction is purely horizontal. Now we're going to take this idea and we're going to stretch on it, and we're going to apply things like friction. And friction always moves in the opposite direction that the player is currently moving. Not which direction the player chose to move, but the direction the player is actually moving. What that means is that with the idea of acceleration and deceleration, I may actually be pressing right and be accelerating so fast and moving so fast that if I instantly hit left, that left movement still has to overcome the right movement, which means even though I'm hitting left, I still may be moving right for a short period of time. So friction is still being acted on against the direction of movement, not the direction of input. So that's very important to understand, that there is a difference and a distinction between the two. So let's go over to the code and take a look at how this actually applies. Where did I put that? There it is. So basically this is all standard data. We're not going to touch this in any way, shape, or form. It's just the size of our screen and the frame rate. What I have done is I've set up a few constants that I want to quickly go over. Now I have a left, a right, and these just represent x directions. So if I'm moving left, my x direction is a -1, which means I'm moving in a negative x direction. Moving right, it's a positive one, so I'm moving in a positive x direction. Flip is just a constant I chose, a constant that means I'm going to flip the direction. So I'm going to multiply the left or the right by -1, and it's going to give me the opposite direction. -1 times -1 gives me 1. 1 times -1 gives me -1. So it just literally flips the direction. If I'm not currently inputting a movement, then I have a constant called no move, which means no input is being brought up. Next, I have a few movement constants that we're going to use within the program. So the first one I have is a maximum speed. How fast the maximum possible speed I'm going to move at. Minimum speed, 0.05. What do you mean minimum speed? What if I'm not moving at all? Well, basically what this does is it gives us a minimum kind of cap, and it says if I'm moving less than this, treat it as not moving at all and just set all acceleration and speeds back to 0. So it's kind of like our safety net saying stop, otherwise we'll never actually reach 0 because we just continually decelerate, 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 decelerate. And then this is how fast we accelerate. 0.3. 0.3 what? Well, 0.3 pixels per update. So if I'm currently moving at a speed of 2 and my acceleration is 0.3, the next update I'm going to move at a speed of 2.3. The one after that, 2.6, then 2.9, then 3.2. You can see it continually applies. And arbitrarily, I set up friction to be half the acceleration rate. So I should decelerate half as fast as I accelerated. So it gives us a nice smoother movement. If you want to decelerate faster, you would just increase this value. Now, of course, if you put it at a value of 1 or greater, you'd never be able to overcome the friction, and your character would not move the way you expect it to move at all. Now, these are just graphical data that I've set up. Mario's image, the scale. This is just to scale the physical size of Mario. And then X speed. How fast am I actually moving in the X direction? Currently, I'm not moving. So it's moving at an X speed of 0. So that's all the basic data that we're dealing with. How do we actually do stuff with it? Well, after I've loaded all my information, nothing special here. I've just loaded the image and I multiplied it by the scale to make it twice its original size. But in the update, this is where we start to do stuff. I'm just going to show you the draw really quickly so you can see I'm not doing anything special in the draw. All I'm doing is drawing the image. All of our work is right here, just in this code. So this entire thing will create this image. So here, if I move to the right, you can see it accelerates and decelerates. Whee and whee. Again, it probably looks pretty choppy to you because you're watching a video that's captured at 10 frames per second, whereas I'm running a program that's running at 60 frames per second. But it does accelerate and decelerate very smoothly on the original. Now, let's take a look at how this actually works. So I've set up a Boolean that says no key press. And currently I'm saying, I'm just checking to see if I have pressed no keys this update. So I haven't yet, so that's true. And I have a local variable called x direction. Which direction am I currently moving? And another local direction, a move direction. So x direction and move direction. X direction represents the direction of movement after an input. Move direction represents the direction I'm actually moving. Remember that demo I discussed about you moving right then quickly switching left? You have to overcome that velocity first. So you may still be moving right even though you're inputting an x direction of left. So that's where that comes into play. So basically, if I hit D or the right button on the keyboard, I'm going to set my x direction to right. I am intending to move right, and I no longer have a no key press. Similarly for left, I'm intending to move left, and I have no key press. If I haven't hit left or right, if I'm not hitting any keys, that means x direction is no move. I'm not moving. And that means that no key press remains to be true. So it is actually still a true value. Now this is where we actually start to apply everything. So I take my current speed, just kind of cover this up for a second, pretend this isn't here for a second. And I'm applying some value to its current value. So I'm adding to the x speed. It's a summation. I'm adding to it. And I'm adding how much? Well, I'm adding the acceleration rate, which is, is 0.3 as we originally set up. And you can see here 0.3. And we're multiplying that 0.3 by the desired direction. So if I hit the right key, that means x direction has a value of 1. 1 times 0.3 is going to give me 0.3. So add that onto the current speed, and we have a new speed. Now we have to detect, well, which way am I actually moving? Well, if the speed is less than 0, that means the move direction is left. Otherwise, it remains to be at right. So we assume that it's going to be moving right. So let's think about this for a second. Let's go back over here. So let's say the beginning of the update, where's my mouse? There we go. The beginning of the update, the first thing I do is I enter in right. That means I set x direction is equal to 1. Acceleration rate doesn't change. Acceleration rate is still 0.3. And speed started at 0. So part 2, we're saying speed is equal to speed plus, that's a plus, multiply or plus acceleration rate multiplied by x direction. Now if we substitute our values in, let's say speed started at 0, we're going to add to that 0.3 multiplied by x direction, which is a value of 1. So that means 0 plus 0.3. That means our speed right now for this update is a value of 0.3. What the? Is a value of 0.3. That means that the player is going to move 0.3 pixels. Wow. Not going to move at all. Okay, that's fine. Because the next update, if I'm still holding right, that means another 0.3 is going to be added to this. So it's going to be 0.6. Still not going to move. Then again, 0.9. Still not going to move. Then again, 1.2. Ah, now we've reached a full pixel. So it's going to move that full pixel. Next one, 1.5, and so on and so forth. And eventually this starts to accelerate, and that speed grows and grows and grows and grows until we reach the maximum speed, at which point we say, hey, stop getting faster. Stop at, I believe we set it at 15 pixels per update. So that would be its cap. Say no more, that's it. That's all you get. So this is how we accelerate. So it slowly accelerates, accelerates. Now the next part was to detect, well, which direction are we actually moving? We need to know which direction we're actually moving. So if the speed is less than 0, that means it has a negative value of speed. That means its speed is physically moving left. That means that we set move direction equal to, I believe we said left, yes, which means -1. Okay, so otherwise it remains at right. So we're actually detecting which direction the character is actually moving in. Not just the desired movement, but which direction they're actually moving in based on their newly calculated speed. So going back over to here. The next step is to apply friction. Well, friction is the exact same thing as acceleration, but the difference here is it always moves in the opposite direction of movement. So instead of just adding friction multiplied by x direction, we're actually going to add on friction multiplied by the negative of the move direction. So if the move direction is right, we want the opposite of that. So we want to apply friction to the left. If the move direction is left, we want to apply friction to the right. Now I've put a little note here that says if we set the x direction to no move, if we do a quick check, if I just do a little statement around here that says if x direction is equal to no move, that means, let me just put that, oops, there we go. If we did this statement here, basically what that means is only apply friction when the user hasn't entered in a value. That's the way Mario works. Mario doesn't apply friction unless the user's not trying to move. So if the user is running to the right, let me just show you. So right now we've taken off that constraint. So this way now friction is only applied when I let go of the key. So I'm going to hit the key right now, and you can see it accelerates a lot faster. And that's because friction is not being applied while I'm holding the key. It only applies when I let go of the key. Whee! So that may be your desired movement. That depends on your game. Just get rid of that. And then the next step, it looks more complicated than it is. Really, all I'm doing is saying cap it between the minimum and maximum x values. Now, I'm just looking at the speeds. I'm not looking at direction in this case. I'm just looking at its actual speed, because speed doesn't have direction implied to it. It's either positive or negative based on its accelerations. So it says, give me the minimum of the maximum speed, which is 15, and the maximum of negative max speed. Wow, what's going on here, right? So basically what we're saying here is, let me just draw this out for you. If we were to draw a number line, we're saying make sure that its speed is between -15 and +15. That's all we're doing. We're saying make sure that it is greater than this value and less than this value. As long as it's within those two bounds, we're good to go. No problems. If it isn't, then we cap it at that value. Alright, so we just say give me the minimum or the maximum of that -15 and the 15. Now, of course, if there isn't a key press at all, now we got to detect whether we should stop moving. So this is where that minimum speed comes in. So if the speed itself, if the x speed itself is less than that minimum speed, which we set at 0.05, then we're going to say just set speed to 0. Set direction to no movement. You're not doing anything. Just stop applying it. Stop doing anything at all. you'll notice that I use math.absolute here because I don't care about direction. I don't care about polarity. I don't care if it's moving left or right. I just want to know the actual value of the speed itself. So the magnitude of it. So if it's positive 5 or negative 5, to me I'm just going to treat those both as 5. If that 5 is less than the minimum speed, then stop moving. Set the x speed to 0 and set the x direction no move. You notice that we actually haven't moved the rectangle yet? Not at all. We haven't even touched it. That happens in the final step. We actually apply the movement. So we take the x value of the destination rectangle and we add on to that the x speed. But you'll notice that we cast it to an integer. What that means is if you have a value of 0.3, the 0.3 gets cut off. It's not that x speed loses its value, it's just treat it right now as an integer. So 0.3 becomes a 0. 0.6 becomes a 0. 0.9 becomes a 0. So the player doesn't even move. However, when we get to 1.2, it does, because 1.2 becomes a 1. So that 1 will be added to the x value. So this is how we achieve our acceleration and our deceleration. So just to demonstrate the video of it one more time, I know it's choppy, but please bear with it. Move to the right, and it decelerates. Move to the left, and it decelerates. Now if I notice how fast it decelerates if I actually don't just let go of the button, I actually switch directions. So I'm holding left and I hit right. It slows down twice as fast because not only am I applying, actually more than twice as fast, not only does friction get applied, but also the opposite move direction is applied as well. This is how the original Mario works in that degree. Okay, so that is acceleration. In the horizontal, although the vertical direction moves, it can work the exact same way. The only difference is you wouldn't have an upward friction force unless you wanted to. Of course you could. And that's it.